Hi, I'm Nathan Schuett. I'm CEO of PRENAV.
I'm Asa Hammond. I'm the CTO of PRENAV.
You know, the original name for PRENAV came from precision navigation, and to us that means very precisely being able to give a robot a path or instructions and have it follow it every time. And that's hard to do with drones because typically they're mostly relying on GPS. But you know, we're building a number of capabilities both onboard and offboard that allow the actual aircraft to do exactly what you tell it to do with centimeter level accuracy, and then translate that into a deliverable that customers really care about, either for inspections, cinematography, virtual reality, environment capture, you know, warehouse stock takes and inventory, construction site monitoring. There's a number of applications where that level of control and repeatability is huge. It's really a game changer.
I've been doing a bunch of work in camera control, and my background is in computer graphics and animation, visual effects for feature films. So there you have this really intense requirements around positioning and posing the camera really accurately in time. So I had worked on gravity, and during the gravity project, we're trying to have these very large camera moves flow through a very large space, and so we had these issues with localizing the camera, so figuring out exactly where the camera was in these large warehouse. So I'd had some ideas around how to do that in a more free-form environment, something that didn't have such a big 10,000-pound camera. And so some of those ideas kind of led to our initial thoughts around drones, and how drones are kind of the perfect fully mobile camera. And the big problem with drones is they don't know where they are, so they can crash into things, and they can move sort of sloppily under GPS. But the fundamental thing that they do have is agility and ability to position themselves pretty much anywhere. So trying to work through how to localize them really well, and once we can close that loop really accurately, then you have this really powerful camera system. One of the key differentiators is we have a ground-based scanner and tracker. And so we're able to, in advance, scan an environment from this fixed reference and get a very accurate understanding of the flight space that we're going to work in.
Yeah, what we're building is a very tightly integrated system between having awareness of what's around you, which we're getting from this ground unit, which laser scans an environment and builds a 3D point cloud of the environment. Very accurate flight control and path planning tools that are three-dimensional in nature, so you can follow the surface of a roof maybe at 45-degree angles, or you can fly all around a very complicated or intricate cell phone tower and plan all that in advance. And then the image processing layer, which is once the drone takes photos from all these vantage points, they're uploaded to the cloud, stitched together into a 3D reconstruction of the asset, and then analyzed to give the customer information about measurements of what's on the structure, is there damage, cracking, and to identify a number of the things that they're looking for.
Certainly, all of the area of robotics is reaping the benefit of the cell phone industry, and how many advances in miniaturization and lower power in cameras, radios, processors. So we're using quite a few processors that are directly from the mobile market. And
yeah, we're taking advantage of new LiDAR sensors that are coming onto market. Image processing algorithms that are sort of the latest research that's coming out of ICRA and various conferences, and trying to think of how best do we apply it to our integrated solution for our customers.